Good morning everybody and welcome to our webinar about lubrication oil treatment with marine engines. My name is Remco de Witte and I am Application Manager for separators based in Stockholm, Sweden. I would like to welcome our panel members Mr. Maxime de Gazot from France, Product Manager for Moati filters within Alfalaval.
Hi Remco.
And Mr. Adrian Hogan, Global Sales Manager for Plate Heat Exchangers in Lund in southwest Sweden.
Thank you, Remco.
So today we will discuss the 2020 fuels and its effect on lubrication oil. The 2020 fuel specification is the same as before 2020. The ISO 8217 specification has not changed. The sulfur content has gone down from 3.50% to 0.50%, and this means that the amount of acid introduced into the lubrication oil has gone down as well. Typical base numbers, base number being the total of alkalinity within the lubrication oil, has gone down from 55 to 40 to compensate for the acidity. When introducing acid into the engine by the fuel oil, you need to have a buffer within the lubrication oil to catch that up and to make sure that the lubrication oil does not become corrosive. But now that the acid level within the fuel oil has come down, this means that that you have a surplus of alkalinity in your lube oil, and that will create deposits on top of the piston crown with all its negative effects. You basically introduce a contaminant in another way. You need to balance the amount of alkalinity, the base number, with the amount of acid coming in, and that requires in this new fuel oil environment a lot stricter monitoring of the base number and the acidity within the lube oil. Instead of once every 3 months doing an analysis and making sure it is okay, I recommend that you do this more often so that you are sure that the balance of alkalinity and acidity is correct. Right now we will start discussing lubrication oil and the purposes of lube oil. And for that I would like to invite Mr. Adrian Hogan to participate with me. Lubrication oil has two purposes. The first is lubricating the engine, obviously. So lubricate the moving parts, pistons and its internals, liners, bearings and so on. But another big part of lubrication oil is cooling. Adrian, can you tell us a little bit more about that?
Yeah, the important part of cooling is that it influences the viscosity of the lube oil. If for some reason we have inefficient cooling, then the viscosity will be too high, and then the flow from the lube oil will be too low.
So if we have too much cooling, then the viscosity will be too high.
Exactly, and of course the pump stem will have to work harder, or probably the flow will actually drop off, and that will influence the lubrication and the cooling in the engine.
Exactly. And what if not all the heat can be removed so that the temperature within the lube oil becomes too high? What will happen then?
Well, if the temperature of the lube oil becomes too high, well then you eventually get an alarm in the system, and this will cause quite a lot of problems. Because if the temperature is too high, the velocity will decrease, of course. And then there's a risk then that the oil film will break, and the lubrication cooling effect, of course, will affect the liners and the pistons, and it will not be sufficient to cool the engine.
Exactly. No, the break of the lube oil film will cause metal-to-metal wear, obviously. So that is something that we want to avoid at all costs. So as you all know, viscosity is mostly affected by temperature, like you said, Adrian. Too high temperature means too low viscosity, oil film breakage. Too much cooling or engine with a cold start means too high viscosity and not enough lube oil reaches the engine, or less lube oil and with its effects as well. Other causes of too high viscosity can be water in oil or particles in oil, and that I would like to take with Maxime. Maxime, what kind of particles or water or anything can enter the engine?
Yes, Sir Remco. As you said, water is one well-known contaminant in LubeOil, but there are many more of various sources. You'll have some combustion byproducts that eventually make their way into the LubeOil, soot, but things like that. And then you also have metal-based contaminants that can be either coming from the fuel as well, like aluminium. That's as an example of cat fines. Silica is another one, of course. But also, and perhaps mainly, you'll find some wear particles. All the moving parts in the engine will gradually wear down, and all those particles will be cleaned off and collected into the LubeOil sump. Other more less problematic, perhaps, are things like organic chemicals, like plastics or paints. And occasionally you can find some fibers as well that can come from maintenance operations by the crew. These are less problematic for the engine, but they could be problematic for some of the ancillary equipments, like the filters. And one last source of contaminants is actually the oil itself. Anytime you're bringing fresh oil into your system, you will bring with it some contaminants that would not be present in an oil that has been operating for some time.
Yes. So what will happen if, like now you say, clean LubeOil brings its own problems, and it can be actually slightly dirtier than LubeOil in circulation. But I guess that only holds if the LubeOil is properly treated, because I think that if the LubeOil is not treated, that all the contaminants that come into the engine will vastly outnumber the particles that would possibly come in with clean LubeOil.
Yes, you're quite right. All the contaminants will, without proper separation, will accumulate and concentrate dramatically over time, and the consequences of that are severe. If, as an example, if you look at a 36 megawatt engine, for instance, a four-stroke engine, if you were to replace one liner of a piston, that's going to cost you about $40,000 just for the material, the part itself. And then you have to add on to that the downtime of your engine, the loss of revenue for the ship is not operating. So let's say maybe $20,000 a day. So day one, you've lost $60,000, and then that just keeps rising day after day. So the consequences of poor oil treatments can be very, very severe.
I hear you on that one. I personally always like to compare LubeOil with blood in the human body. It is absolutely critical. Without LubeOil, your engine will not survive. And if the lubrication oil gets affected, the engine will be severely damaged in all kinds of ways. To demonstrate how the lubrication treatment system works in a ship, I would like to introduce the LubeOil line video now. This video will demonstrate how the recirculation loops of LubeOil function within a typical ship set. We will be back after the video.
Lubrication oil is an essential part of vessel operations and plays an important role in engine efficiency and overall engine lifetime. The cleaner you can keep the lubrication oil, the better it is for the engine. Effective cleaning also means the oil needs to be replaced less often, saving time and money in the long term. Alfalaval can offer the optimal solution to ensure your lubrication oil stays cleaner and lasts longer, while helping to ensure that your engine stays protected. Let's take a look at how the system works. Used lubrication oil from the engine makes its way to the sump tank, and from here it is pumped through a small heat exchange. Here, the oil is heated before arriving at the separator. The lubrication oil is then pumped into the Alfalaval high-speed separator, where the centrifugal force removes potentially harmful particles and contaminants, leaving a lubrication oil that's ready to be reused in the engine. Without continuous cleaning of the oil through separation, the byproducts of combustion are not removed and will be recirculated in the engine. This can cause increased engine wear and even seizure, so this part of the process is absolutely essential. It's then pumped through an Alfalaval heat exchanger to cool the oil before it reaches the Alfalaval Moati filter. The Moati filter's primary function is to protect the engine. The lubrication oil passes through a fine mesh where harmful particles are trapped. The filtration capacity is always maintained thanks to continuous backflushing, which ensures no solids are retained on the surface of the filter mesh. This is done at the same time as the oil is being filtered and pumped to the engine, leading to a constant and very low pressure drop across the filter. In addition, the Moati filter contributes to the oil cleaning by removing sludge by means of a diversion chamber or a self-spinning centrifuge on the backflush line. Finally, the cleaned and filtered lubrication oil reaches the engine, where it is used to make everything run as smoothly and efficiently as possible. This cycle of lubrication oil cleaning is constant and helps ensure maximum uptime and engine productivity whilst minimizing the need for maintenance and new lubrication oil. To learn more about lubrication oil, visit the Alfalaval Marine website.
Welcome back to the webinar. We would now like to discuss the various equipment that you've seen in the video. The separator typically removes water, particles less than 4 or 5 micron, soot because it can continuously discharge without clogging up. So the question comes, why is the separator not installed in line with the filter and the cooler? Why is it on a separate line? Maxime, can you please elaborate on this?
Sure. The main factor we have to consider here is flow rate. If the separator were to treat the full flow of oil to the engine, it would either not be very efficient or it would be very, very, very big and therefore very expensive. So it's not a cost-effective solution. To give you a sense of the flow rates that we are talking about here, let's take an example of a trunk piston engine running on HFO, let's say 19 megawatt engine. The flow rate to the separator is going to be around 5.5 cubic meters an hour of lube oil. But the overall flow, the oil going to the engine to perform its cooling and lubrication job, is 250 cubic meters an hour. So the orders of magnitude are really, really different. So the cost-effective way to protect the engine is to have the in-depth treatment on a side stream through the separator, and then last line of defense, stopping any particles that haven't been removed yet by the separator with the filter as close as possible to the engine.
Yes. So the separator needs heat to work properly. The lower the viscosity to the separator, the more efficient separation will be. Separation temperatures are typically raised from 45 degrees Celsius of the sump to 95, 98 degrees Celsius in the separator. That heat will be removed in the cooler towards the engine. Adrian, is there a way to do this more efficient?
Yes, as you mentioned, during the separation, we are adding sufficient amount of kilowatts. It can be from 20 kilowatts up to 200 or 300 kilowatts into the LubeOil system, and this also has to be taken care of. However, there is an opportunity where we can reduce this heat load by heating up the incoming LubeOil to the separator by the outgoing warm LubeOil. And this way you can halve the heat load. This is especially cost reduction if you have electric heating on your high-speed separator system, so you can reduce the electric heat load.
Absolutely, because to give some perspective, the amount of energy going into the heating of the oil for the separator is a magnitude higher than the power consumed by the separator itself. So it can be 5-6 times as high or even more just to heat up the oil. So any energy that you can recover or save, and that does not have to be heated up, will both be will have an environmental impact as well as an economical impact. And installing a plate heat exchanger is very, very easy, can be done on the spot. When we get approached by a customer, we three of us represent the major groups that deal with LubeOil treatment around the engine. We work together to get the best possible products as a total picture. So how do we do that? I would like to ask you, we have a full flow filter and a full flow cooler in series with each other. How do they affect each other?
Yeah, if I take this one first, when it comes to the heat exchanger, the pressure drop affects enormously the size of the heat exchanger. So we need to optimize this pressure drop with the heat exchanger, and also to make sure, together with the pressure drop across the filter, that we don't utilize too high a pressure drop, because we all know pressure drop costs money. So that's why we optimize for the heater. For the cooler, we optimize the pressure drop according to the design requirements. So it's a trade-off there.
Yes, Adrian, you're quite right. You mentioned the pressure drop for the filter. It's also a very important factor. As a matter of fact, the filters need to be designed with that in mind, so that an efficient continuous backflush is implemented, so that the filtration capacity is always maintained. And that means the pressure drop is as low as possible, and it's also as constant as possible during operation. And that is also connected to the separator in a way, because if the separator is not sized and designed in accordance to the rest of the equipment, then we have other issues, particularly with the filter.
So for example, if the separator fails, for example, the engine can still keep on running. But what happens if the separator fails for a week? Do you notice that on your filter?
Yes, indeed. After some time, the particulate load in the overall LubeOil sump and system will rise quite significantly. And eventually, the filter will not be able to cope. Any filter has a design specification for particulate load. So it's usually linked to the type of fuel that the engine is burning and so on. But once we exceed that capacity, however efficient the self-cleaning function of the filter may be, it will clog eventually, or fail, which would be even worse for the engine.
Yeah. Yes. Then you need to overhaul the filter in the best case scenario. And
that would be the best case scenario. Yes, you can just clean your filter and put it back in service. But if you haven't fixed the problem with the separator, it will just clog again eventually.
Yeah. Yes. And stopping the filter means stopping the engine.
If it's only a simplex, yes. Larger engines will have duplex filters where you can run a bypass.
So that concludes our discussions for today. I would like to thank you, Adrian, and you, Maxims, for your contributions today.
Thank you.
So today we discussed the effects of 2020 fuel oil on lubrication oil. We showed a video on LubeOil treatment, and we discussed the various equipment within the video and the way the equipment works with each other. I would like to thank you all for your attention, and I would like to invite you for a question and answer session now.